Chapter 10, Section 7, Permutations and Combinations. The objective: learn to find permutations and combinations. The factorial of a number is the product of all whole numbers from the number down to 1. The factorial of 0 is defined to be 1. 5 factorial can be written as 5 with an exclamation point behind it, and that equals 5 times 4 times 3 times 2 times 1, which equals 120. Example 1, evaluating expressions containing factorials. 9 factorial equals the product of 9, 8, 7, 6, 5, 4, 3, 2, and 1. Please calculate that and write your answer here. Now some calculators have the factorial button, so you might want to look for that on your calculator. In letter B, we want to find 8 factorial divided by 6 factorial. Now if we write that out, we would have in the numerator 8 times 7 times 6 times 5 times 4 times 3 times 2 divided by 6 times 5 times 4 times 3 times 2 times 1. Now you can simplify this before you go ahead and punch all these numbers in. We have 6 times 5 times 4 times 3 times 2 times 1 in the denominator. That will cancel out. That will divide out these numbers in the numerator. So we would only have left 8 times 7. So calculate that and write your answer here. In letter C, 10 factorial divided by 9 minus 2 factorial. So let's simplify the denominator first. Our numerator would still be 10 factorial. In our denominator, however, we would have 7 factorial. Now before you punch this into your calculator, you may want to recall over here that in the numerator, these factors 6, 5, 4, 3, 2, 1 could be divided out by these factors in the denominator, and you are only left with 8 and 7 as factors in the numerator. So you may want to think about that over here before you punch this into a calculator. But either way, calculate this and write your answer here. A permutation is an arrangement of things in a certain order. If no letter can be used more than once, there are 60 permutations of the first 5 letters of the alphabet when you take 3 at a time. So we have ABE, ACD, ACE, ADB, ADC, etc., etc. For the first letter, there are 5 choices. Once that first letter is chosen, the second letter, you only have 4 choices. Once these 2 letters have been chosen, the third letter only has 3 choices. So we would have 5 times 4 times 3 would come out with a total of 60 permutations. Notice that the product can be written as a quotient of factorials. 60 equals 5 times 4 times 3. In our numerator, we had 5 choices, 5 factorial, and we are taking 3 at a time. So the difference would be 2. So we'd have 2 factorial in the denominator. So 5 factorial divided by 2 factorial came up with 60. Permutations. The number of permutations of n things taken r at a time is n p r, where n is in the numerator, and that's factorial. In the denominator, we'd have n minus r factorial. Now permutations, remember, permutations, order matters. So when you think about a race in track and field, a 100-meter race, the order in which the runners finish, that matters. So the difference ways that the runners could finish in that race, that would be an example of a permutation. And remember, down here, by definition, 0 factorial equals 1. Example 2, finding permutations. Jim has 6 books. Find the number of orders in which the 6 books can be arranged on the shelf. There are a total of 6 books, and the books are arranged 6 at a time. So we have 6p6. Now if we follow the formula for a permutation, this first 6 is in the numerator, and that's 6 factorial. In the denominator, we would take the 6 minus 6, simplify this to 6 factorial divided by 0 factorial. Now remember, 0 factorial is defined as 1. So we need to simplify this and write our answer here. Another example there are 7 soup cans in the pantry. If the shelf has only enough room for 4 of those cans, find the number of ways 4 of the cans can be arranged. So we have 7p4. So that would be 7 factorial divided by 7 minus 4 factorial. Please calculate this and write your answer on the blank. A combination is a selection of things in any order. So it's different than a permutation. Permutation was order matters. With a combination, order doesn't matter. You can kind of think of a combination as a pizza. If you're going to order pepperoni and olives, it doesn't matter if it's pepperoni first and then olives, or olives and then pepperoni. That combination is the same. So a selection of things in any order is a combination. If no letter can be used more than once, there's only one combination of the first 3 letters of the alphabet. ABC, CBA, BAC, BCA, CAB, and CBA. These are all considered to be the same combination of A, B, C because order doesn't matter. Kind of like a peanut butter and jelly sandwich. If no letter is used more than once, there are 10 combinations of the first 5 letters of the alphabet when you take 3 at a time. To see this, look at the list of permutations below. With the first 5 letters of the alphabet, here are all the permutations, all 60 of them. These 6 permutations are all the same combination. These 6 right here are all the same combination. They all contain 1A, 1B, and 1C. In the list of 60 permutations, each combination is repeated 6 times. ABC is repeated here. ABD is all repeated here. The combination of ABE is repeated here. The combination of ACD is repeated here. Each combination is repeated 6 times. So the number of combinations is 60 divided by 6, which equals 10. There are 10 combinations of the first 5 letters of the alphabet. Again, combination order does not matter. Combinations. The number of combinations of n things taken r at a time would be read as n choose r, which n would be in the numerator as a factorial. In the denominator, we would have r factorial times n minus r factorial. Example 3, choosing combinations. Mary wants to join a book club that offers a choice of 10 new books each month. If Mary wants to buy 2 books, find the number of different pairs she can buy. On the left, we have 10, and that 10 represents the possible books. On the right of the C, we have 2. 2 books are chosen at a time. This would be read as 10 choose 2. If we follow the formula, the 10 is in the numerator, 10 factorial. And that is set over 2 factorial times 10 minus 2 factorial. Simplify the 10 minus 2, and that would come out to be 8 factorial. Now we would have 10 factorial over 2 factorial times 8 factorial. Remember, we can simplify, we can divide out common factors in the numerator and denominator, then calculate your answer right here. This answer represents the number of combination. This means that Mary could buy this many different pairs of books.